Loading. Okay, there we go. Hi, everyone.
Hey, everyone.
Hope you're all doing well. We'll wait a few minutes before we start everything. If you're in the chat, just let us know where you're coming from. So I'm Alex DeStassi. I'm a curriculum developer with Codecademy.
Jamie Rich. I'm also a curriculum developer at Codecademy. Yeah.
And today you're joining us with our back to school campaign where we're going to go over Python loops. So we'll wait a little bit longer and then we'll just get into it. What our plan for today is first we're going to go and we're going to talk about the concept of loops and just kind of get an understanding about what they are and the different kinds of loops that we can use. Then we'll jump over to see how we can use each of these loops in Python. And then once we get comfortable with that, we'll move on and we'll do some cool code challenges together where we'll put our new knowledge of Python loops to use.
Yeah, and I am also going to be answering any questions in the chat and explaining the concepts along with Alex. We're all really excited.
Mm-hmm. Okay. Again, hi everyone who's joining in. Love seeing all the different places everyone's from, so it's really cool. All right. So I'm actually going to go ahead and I'm going to start sharing my screen. Okay, so again, you're joining us with our CS101 live stream series. And if you just go down the syllabus page, you'll see that we're passing all the things we've done before. Last week, you joined us for lists. And then this week, you're joining us for loops. So you're going to want to go over to this section that's CS101 loops. And you can see we have 2 lessons and an article. So we're going to start off with that first loops lesson. So again, I'll just give you guys a little bit just to get there. Okay, so I already have my loops open over here. So let's start talking about loops, and what better place to start than introduction to loops. How do we use code to tell a computer this? Create a variable and call a function 15 times. So what we know from what we've done so far is that this looks like create a variable, call a function, create a variable, call a function, create a variable, call a function. And you can already see that it's starting to get very repetitive fast. So it takes a long time. We can make a bunch of mistakes. Maybe the 3rd time we call the function, we spell the function name wrong, and then we have an error. So again, it's not the most efficient way to do things in programming. So instead, we can have our instructions do something like this. Repeat the following 15 times. Create a variable, call a function. So this took a lot less code. So we can see that in our top piece over here, we only did the create a variable, call a function 3 times. And that took up 6 lines of code. But here, all 15 times we have to repeat the instructions, it's done in 3 lines of code. So it's super, super helpful. And that structure is a loop. And with a loop, it's just giving us the ability to repeat a block of code a certain number of times. Okay, so today we're going to be covering 3 types of loops: for loops, while loops, and for each loops. And again, I hope you joined us in the previous lessons because we're going to use a lot of those concepts that we've gone over before during this lesson. So variables, operators, calling functions, and working with lists. Okay, so let's take a look at this nice example that we have in front of us. We're going to create a pattern without loops. So in the text box, we'll repeat the instructions 10 times and then run it. So we need to place a pink tile, an orange tile, and a mint tile. So I'll just do that by clicking over here. So we have our pink tile, orange tile, mint tile. And you can see as I click it, it just appears in this text box over here. So that's 1, and we have to do this 9 more times. So pink, orange, mint, pink, orange, mint. You can see that this is already getting very repetitive, and that since I'm talking, I've already lost count. So you see that this isn't the most efficient way, so I'm just going to keep going. And if you're thinking to yourself, yes, I understand, you have to place the pink tile, the orange tile, and the mint tile, we get it, then you're ready for loops. So I'm going to run this code, and we're going to hope that I got all of it done. And you see, we still didn't even get there. Okay, here we go. Pink, orange, mint, pink, orange, mint. We'll run that one more time. And you can see we finally covered all the things in our tile. And that took a while, and it was kind of clunky. Thank you, Jamie. So we're going to move on to the next piece, and we're going to learn how we can do this again in a much more efficient way. And to start, we'll learn about for loops. So with for loops, you can think of them as count-controlled loops. When we create a for loop, we know from the get-go exactly how many times it's going to repeat the instructions contained within its body. So let's take a look at an example over here. We can see it's the same example as we saw before, but instead it says for 10 times, place the pink tile, the orange tile, and the mint. And so you can see it's the same thing over and over. We're still using that place tile function. So when our computer receives this program, we have our counter set to 0, and then it executes the instructions in the body of the loop. And after each iteration, which each iteration is just all the instructions. So once it places all those tiles, then it'll go on to the next iteration and start repeating again. And our counter increases by 1. And then that process is going to continue to repeat until our counter is 10. And then all 10 iterations are complete and our loop will stop. So again, like I mentioned before, for loops are useful when you know how many times you want a program to repeat a task. So for example, printing 3 copies of a document or inserting 8 rows into a table. For loops are good when you know what you want. So let's go over to this nice example over here. We're going to do the same thing before, but we're going to try and use a for loop to accomplish it. So let's take a look. We need to insert our 3 instructions. So we're going to place our pink tile, our orange tile, and our mint tile. And then we're going to select the number of times the loop should run. So when I click over here, it says loop for, and then I get to choose an option. So I'm going to have it run 10 times because that's going to place all 30 tiles down. So I'm going to hit this and let's run it and see what happens. So we can see that once I start running it, we see that pink, orange, a mint, pink, orange, mint, all running together. And then that covers the board. And that took so much less time than what we did previously, where we were clicking each of the instructions so many times and then we still didn't complete the whole board.
You can also imagine that in this case, Alex just had to click on things. Imagine if you had to like retype every single one of the lines, and that would just even be worse. Yeah. Also imagine if there was more than just 3 instructions you're trying to go through. If you were trying to repeat 10 lines of code like 15 times, that's a lot of code you have to write. Yeah. Okay, so now that we have a little bit of an understanding on for loops, we're going to move on to our next loop. And that's while loops. So let's think about approaching our tile placing another way. We don't know how many tiles we need to place, but we know when we need to stop placing tiles. Another way you can think of it is if you are ever filling up a bathtub with water, you will have it keep running water until it hits that top point. So, and then you stop it so it doesn't overflow. So try to have that concept in mind as we go into while loops. We don't always know how long our while loop is going to run, but we know when we want it to stop. Okay. And so while loops also kind of combine loops and conditions because we're going to need to place a condition
inside our while loop in order for our program to know when to stop running. So we have an example over here. So while there are still pink tiles available, place the pink tile, place the orange tile, place the mint tile. So that's our while loop or condition controlled loop. It repeats a set of instructions while that condition is true. So in this case, the computer will place tiles while there are still pink tiles available. So going further into it, in a while loop, the computer checks if the condition is satisfied. So once that condition is met, it stops executing the tasks. But if it's not met, it's going to continue iterating. So again, it keeps going and going. And there's a slight risk in while loops where you could cause an infinite loop, but we'll get into that later. So when to use a while loop? Use it when you know when a program should stop, but you're not quite sure the number of times you need your code to repeat itself. Okay, so let's take a look at this task we have at hand. So we're going to do the same tile placing, but this time with a while loop. So I'm going to place the pink, the orange, and the mint. And then we need to select a condition. So we can see we have a few options over here. And let's see, we can choose if there are empty slots, under 9 tiles are placed, under 15, or while the computer is running. So what happens if we just click under 15 tiles are placed? I want to see what happens. So we run this code and it looks just like it did before. And we can see that everything's going in, but our while loop stopped. And that's because we hit the condition that under 15 tiles are placed. Once that condition became false, then we stopped. It stopped running. Now, what we really need to do is use while there are empty slots. So let's see what happens. We're going to run our code again. So you can see now it's going to continue going, and it's going to stop right when it hits that final point where there are no more gray tile spaces, and every single one of those is already taken up. Great, so again, that's the while loop. And now we're going to move on to the next one, for each loops, which I think are always fun. And while we're going into for each loops, this is where you're going to have to kind of remember all that stuff we talked about with lists. Because when we use a for each loop, we're actually iterating through a list. So the best way we can think of this is, let's take a look at our example again. We define a sequence of desired tile colors. So that's going to be our list. And tell the computer to repeat the instructions for each item in the sequence or the list. So let's take a look at this nice example we have over here. We have a list. It's called festive list. It's pink, green, red, pink, green, red. Our loop for this would be for each color that's in our festive list, we're going to place the tile. So what happens when we use a for each loop is it's going to access the element of every single item in a list. So each one. So this is when you know, you don't have to know too much. You just have to know the size of your list, and your program's going to do the rest. So you may have noticed that the program looks a little shorter than the ones we used before. That's because we only need to write place list once, because the pink, green, red repetition is already described in the list. Okay. So the sequence we used above was a list, but we can use other similar data types. The umbrella term for those is collection, so we may also call for each loops collection loops. So like we've been discussing, use this loop when you need to perform a task for every item in a list, or when the order of things must be maintained. In this case, in our lights case, both were important. A tile must be placed for each item in the list, and the order of them is essential to the pattern. Okay, so here we go. We're going to do this again. We're going to place the same 30 tiles as before, but this time we're using a for each loop. So if we look at our example in front of us, we have 3 lists to look at. We have a festive list, and inside we have different items. It's pink, green, red, pink, green, red. continuing on, continuing on. We have our moody list, which is blue, purple, silver, and that's just going to repeat a bunch of times. And then we have the pastel list that we've come to know and love, which is pink, orange, mint, pink, orange, mint. And so
my personal favorite.
Right? It's the best one.
Yeah.
Okay, so now let's have this work. So we already have the first part of the code ready. Place tile color, loop for each. And then we're going to choose what value for each color in festive list, and each color in moody list, or for each color in pastel list. So I'm going to choose pastel list, and we're going to run our code. So you can see it's everything we already know. It's going through every single item in this list. So I wonder if I can highlight it. Yes, I can highlight it. So every single item in this list, it's going to iterate through, and it's going to place that tile. Great. Jamie, do we have any questions or comments from anyone?
I don't think so, but if anyone has any questions or comments, or if they want to see what either the festive list or the moody list look like, maybe we can try those out.
Yeah. I think it's a great idea. Do you want to go with the festive list or the moody list?
You know, I'm feeling a little bit more festive right now than moody,
right.
So
let's run it. So you can see that it's going to perform the same task, but it's going to do it with the different color items, because that's what the list said. So one nice thing is that we can use this with different lists, and it's nice in that way because we didn't have to change much of our code. We just had to specify which list we need it to iterate through. Okay, so moving right along, let's put it all together. And we're going to actually kind of look at what this looks like in Python. So a lot of things that are going to go on here. We're going to use some variables, operators, data types, functions, control flow, lists, and loops. Okay, so below we have a few examples. And if you're looking at the syntax and you're very confused, don't worry, because we're going to go over it in just a moment. So I'm going to copy this and I'm going to paste this right into my code. So what this is saying here, well, you know what, we'll run it first. So I'll run this code. You can see it's already placing these different things. It's a different, now we're doing mint, orange, mint. So this one is actually representing a for loop. So what it's saying is we're going to have this repeat X number of times. And in this case, 10 times. We know exactly how many times it's going to repeat. And now let's kind of take a look. Let's replace this and we'll do it with a while loop. Okay, so here we go. We have our while loop in Python. So while we have a variable that's less than 10, we're going to place orange. We're going to place mint, then orange, then mint. And at the last part, we're going to increase I by 1. And again, we'll talk more about why this happens when we get to it in our lesson. But this is just to make sure we don't run into an infinite loop. So let's run this code. You can see it accomplishes the same thing. So that's something to be aware of. For loops, you can write an equivalent for loop as a while loop. It's really kind of up to you what you're trying to go for. A for each loop is a little bit different because you need to have some type of collection to iterate through. But whatever you can write as a while loop, you can technically, in most cases, write an equivalent for loop. Okay, so let's just go and take a look at this review. A loop is a structure in programming where the instructions are written once, but a computer can execute them multiple times. Each execution of those instructions is called an iteration. For loops, or count-controlled loops, repeat for a specified number of times. While loops, or condition-controlled loops, repeat until a condition changes. And finally, for each loops, or collection-controlled loops, repeat instructions for each item in a collection. Okay. So now, we're not going to do the example here, because this is just letting us play around with it, but we are going to go into the next section. So I'm going to actually take this out. You could hit the next button if you like, but if you're in the catalog taking a look at this, the syllabus, you can actually now go to that second loops lesson. I'm going to open this in a new tab. Okay. Great. So we're in introduction. And before I move on, I'll just check in with Jamie again. Do we have any questions or anyone have any comments about loops so far?
So someone had a question. I just answered it. Let me see. I might have to scroll up. Oh, Pepito Suarez asked what the difference between the first for loop we went over versus the for each loop we went over.
Okay.
If you want to like quickly go over that? But,
yeah, sure. Yeah. So the difference is with the for loop, we knew exactly how many times we wanted to repeat an instruction. And we created the iteration sequence ourselves because we specified we want you to start at 0 and we want you to end at, let's say, 10. So we're saying you're going to repeat these instructions 10 times. Now, the for each loop is a little bit different. That one, we're going through a collection, kind of like a list. So for every item in a list, whether that list is 10 items long or 100 items long, the same instructions are going to be applied to each element in the list until every single element in that list has been covered. That about sums it up. What did you say, Jamie?
I said pretty much the same thing.
Cool.
That basically the first for loop was just a certain number of times, while the for each loop is going through items in a list till you get to the end.
Awesome.
And they're both pretty much syntactically similar in Python, which we'll show, with just like subtle differences.
And actually, you can use a for loop to iterate through a collection. So we'll cover that. Okay. So let's actually start looking at these loops in Python. And we have an example. Suppose we want to print each item from a list of dog breeds. We would need to use the following code snippet. So again, what we're looking at here is trying to print out every item of a list without loops. So what we do is we print dog breeds at index 0, then we print it again at index 1, we print it again at index 2, index 3, index 4. And you can see that it's not that inefficient, because what if we had a list that was 100 items long? Would we write 100 print statements so we can see every item in that list? We could, but it would take a very long time. So luckily, as we now know, Python gives us an easier way to do this by iterating through every item in a list. We can use loops. So in this example, we're probably going to be going through a for each loop, because I know that we're going to be iterating through a list. So once again, in this lesson, we'll be learning about loops that let us move through each item in a list, loops that keep going until we tell them to stop, and then loops that create new lists. All right.
Yeah.
Interesting.
And the loops that create new lists called list comprehensions are not something we went over in the previous lesson. So it'll be like a new cool thing towards the end. And they're like definitely my favorite type of for loop personally.
So guys, you're getting a surprise edition.
Yeah.
Okay, so first let's paste the following code into a script.py. So I'm just going to follow that. So we can see already in script.py, we have a list. It's called dog breeds. We have items French Bulldog, Dalmatian, Shih Tzu, Poodle, Collie. And now we're going to print each of these items out. And this is using the for each loop. So we'll go over that more in the next one, but basically it's so much easier to print those all out. We only needed 2 lines of code to print every item, unlike here, where we needed 5 lines of code. And again, this would change. If our list was 30, 50, 100 items long, we would still only need 2 lines of code, these 2 lines of code right here, to print out every item in that list. Okay. So first, we're going to go over creating a for loop. And so this is going into how to use a for loop, a for each loop. Sometimes this goes back and forth in terms of what it's called. It is a for each loop, even though it is also technically called a for loop here. So we're going to learn how to use a for loop to go through a list of collections. Okay, so for loops let us perform an action on each item in a list. Using an element of a list is known as iterating, as we discussed before. So let's actually kind of go into the syntax, the Python syntax of how we accomplish this. So the general way of writing our loop is for a temporary variable in a list, do something. So there's two keywords that we're actually looking at here. One is the for keyword, and two is the in keyword. So when we say for, this kind of lets our program know that we're going to start repeating something for X number of times. Then we'll learn about the temporary variable. So this temporary variable is almost like a loop control variable. It's going to represent each of our iterations, and we can use it inside the body of our loop, and we can use it to kind of grab elements of a list, but we'll see that. Then we have the in keyword, and that's going to let our compiler know that we're going to loop through something inside of a list. So for our temporary variable, in the keyword, and then we're going to add in our list variable. And then underneath that, inside the body of it, we're going to perform an action. So let's take a closer look at an example of this. So for I in dog breeds, print I. Now, why did we choose I for a temporary variable? Well, we can actually choose any name for our temporary variable. So we can see right under this, we see for dog in dog breeds, print dog. The interesting part is it's going to print the same thing. We can name our temporary variable anything. Dog is a little bit better in this case just because it relates to our list, but there's no problem with going with I. So one thing to notice that with all of these examples, the print statement is indented. Everything in the same level of indentation after the for loop declaration is included in the for loop and run for every indentation. If we don't indent, we'll get an indentation error. Okay, so let's run this code. We can see immediately we get an error. Indentation error, expected an indented block. So this comes from line 6 over here because it's not indented correctly. So if we just indent that like that, we can see now it's inside of our loop. So if I run this now, we can see that everything prints. So if we look at board games, we have Settlers of Catan, Carcassonne, Power Grid, and 2 other ones. So for every item in that list, all we're doing is printing that item. So now let's write our own for each loop that prints each sport in sport games. Okay, so let's actually give this a try. So first I'm going to use that for keyword, and then I'm going to specify my loop control variable. So I'm just going to do that. In this case, they want us to use they want us to name this value sport. Then I'm going to use the in keyword. That lets us know that we're going to use a list. And in this case, we're going to use sport games. Sport games. I'll put my colon there. And then when I go in, you can see that it usually automatically indents it for you because it knows that if we want something to happen inside the loop, it needs to be inside the loop. Okay. And all we're going to do is use a print statement. So I'm going to print the value of sport. So I run this code, and now we can see that it went ahead and printed every item in the order that it appears. So we saw football, football, American, hockey, baseball, cricket. So the order that it appears in our list is the order that it was iterated through and printed. Great. So now we're going to talk about using range. And so this is a little bit more common to what we saw before with for loops in our previous exercise where we were working with the tiles. This is where we're going to specify how many times we want it to repeat. So this time we're not going to use a list to go through it. So as I said before, we're not always going to be iterating through a specific list. We'll just want to do an action multiple times. For example, if we wanted to print out a warning text 3 times, we would say something like the following. So you can see here, for I in a list of length 3, print warning. So we had to iterate through a list of length 3, but we didn't care what was in that list. To create these lists of length n, we can also use the range function. So range, another keyword to keep in mind, takes in a number n as input and returns a list from 0 to n minus 1. what does that mean? So if we look at this example here, we see 0 through 5 equals range 6. And now that value of 0 through 5 is the list that contains the values 0, 1, 2, 3, 4, 5. And Jamie, can you say why it's starting at 0?
So this is basically just a Python thing. It can differ in other languages, but Python is what we call zero indexed. So because of that, when you just give range like one specific number, so if I do like range 7, range 6, whatever, it's going to start at 1, and then it's actually going to end before the number I specify. So for range 6, since we give the parameter 6, it's going to go from 0, 1, 2, 3, 4, 5, and end at 5. Other programming languages might be different. They might be indexed at 1. So it's important to know, like, depending on what programming language you use, to know this, because you may have to like change up your for loop or like whatever function you're using, depending on if it's 0 indexed or 1 indexed.
Thank you. So, and this might be very similar to what we learned in the list last week, where indexes in Python start at 0. So this is coming back to us in our lists. So we can actually do that warning program that we tried to before, just by writing for I in range and then having our value 3 inside of our range print warning. And that's going to print warning, warning, warning. So let's use our range function of for loop to print out the value of promise, which is on line 1, 5 times. So we're going to try this for I in, and now we're going to say what list we're going to use. And we're going to use the range function to create this list. So I'm going to type in range, and it says 5 times. So I'm just going to use 5, colon, and then we're going to go to that next piece, and we're going to print promise. Okay, so let's run this code, and we can see I will not chew gum in class is printed 5 times. And just to make sure we have an idea of this, if I were to just say, let's not care about promise, what if I just wanted to print I? What would happen? You can see that it starts at 0, it prints 0, 1, 2, 3, 4. So just try and keep that in mind. And you can see how much easier it is, because let's say I wanted to print out the first 20 numbers. You can see that it doesn't matter that I want to print more values or create a larger range. It's still just going to take those 2 lines of code to output this value. Okay.
One important note about range, which I feel like some people have this question on their mind, is you can actually specify range to start at a different number than 0. You're not always stuck at starting at 0. And there's also like many different other things you can do with the range function. But yeah.
I'm so happy you mentioned that.
Yeah.
Because we're going to do that. All right, so just like Jamie said, this means we have to set our values inside our range function a little bit differently. So let's say I wanted to start at 10. So instead of starting at index 0, we're going to start at 10. I'd add a comma, and then I believe what I would say is where I want it to end next. So let's say I wanted to end at 20. Let's see what happens, if this works or if this breaks things. It doesn't. So you can see that now it's going to print 10, 11, 12, 13, 14, all the way up to 19. So again, it's just like Jamie said, it's our first value is where it starts. Our second value, it's going to end one value before that. And that's something that could trip you up when you're first starting with loops. So just always remember that that's going to be the case. Now, the one other special thing we'll jump in before moving on to the next piece is we can say what our iteration is. So in this case, we say 10 and then 11, then 12, because we're only adding 1 to I. But by adding one more comma, and I believe if I just write, let's say 2, let's see what happens. Will it break? It doesn't break, it actually works. And it's going to print every other iteration. So we start at 10, then it's going to say plus 2, so our next one's 12, plus 2, 14, plus 2, 16, plus 2, 18. I'm really glad you mentioned that because I think that's just a very fun part of range.
Yeah, I like when I use new functions to look up what all the different parameters you can put in it are, because they're fun to play around with. And range has a lot of cool different things.
Okay. Oh, so here's something we discussed a little bit before. Infinite loops. These are loops that are problematic because they run forever. So in preparation of me knowing that we're going to run this, I'm actually going to get a duplicate tab. You'll understand. So let's take a look at this example over here. We have a list of my favorite numbers, and we have 5 numbers in there. For each value in my favorite numbers, we're going to append 1. So when we run this code, it's going to be never ending, because at what point do we stop? As we append items to our list, that list gets bigger. So there's never a point where a loop can stop. So it's going to run infinitely. This is a problem. It's dangerous for your code. A program that hits an infinite loop often becomes completely unusable. And so the best course of action is to never write an infinite loop, but being learners, sometimes it happens and we're gonna make that mistake. If we accidentally stumble into an infinite loop while developing on our own machine, we can end it by hitting Control-C to terminate the program, because that's the only solution at that point. Now, if you're writing code in our online editor, like we are here, we're gonna have to refresh the page. So let's take a look. We have 2 lists of students, students period A, students period B. Let's write a for loop that goes through each student in student period A and adds it to the end of students period B. Okay, let's give this a try. So I'm gonna write for student in students period A. We're going to say and append it to. Okay, then we're gonna say students period B dot append student. So we'll run that, and let's kind of see what this really did. So we're going to go ahead and we're going to print student. So Alex, Brianna, Sherry, and Danielle, those 4 items are actually now in students period B. So if I actually go really quick and let's say we'll print students period B, we can see now our students period B contains all of those students because we appended them into that. And I believe append we learned about in the previous lesson on lists. So let's say we made a typo. And instead of using students period B, we actually appended it to students period A. I'm going to copy this real quick. What happens now? So we're going through every item in students period A, and we're going to append student to student period A. So this, when we run it,
is not going to be happy.
No. We're just going to be waiting here because there's no way this will ever end. So we can't even process it. So you can see that we're just having issues here. So it's not going to happen. You can see that it disconnected, reconnected, and we still have that loading bar happening. So what I'm going to do is I'm just going to X that out. And I copied our code. So now we can go back in and fix our code so that we fix this infinite loop. Awesome. Okay, so I do have to run all of these again. So there we go. We fixed our infinite loop and everything's fixed. So I'm actually going to skip ahead to while loops for now, but definitely feel free if you're going through this on your own, take a look at break and continue. They're super useful inside our loops. But I want to go make sure that we have enough time to go through some of our challenge projects. So now let's take a look at how we can use a while loop. Now we already remember that using a while loop, it's condition controlled. So as long as something's true, we're going to continue repeating the content of the code. So let's take a look. And we can still use while loops to iterate through lists. So we'll see this example here. We have our dog breeds list. We create an index value. And while our index value is smaller than the length of dog breed, and our length for this is 5, we're going to print the value at that index, and we're going to increase index by 1. And the reason we increase index by 1 is to prevent the while loop. If we don't use that, then we're always going to have an index that's smaller than the length of dog breeds. So there's never going to be a stopping point for a while loop, and we're just going to have to refresh our page again. So every time the condition of the while loop, in this case index is less than length of dog breeds, is satisfied, the code inside the while loops run. Okay, you are adding students to a poetry class, the size of which is capped at 6. While the length of students in poetry list is less than 6, use pop to take a student off of the all students list and add it to the students in poetry list. So if you remember, the .pop function just takes off a value from a list. So we'll see this in action. So let's see. So while the length of students in poetry is less than 6, what we're going to do is we're going to say students in poetry dot append all students dot pop. And at the end, I do just want to print this students in poetry. And I also want to print out all students. So we'll take a look at it all. So there we go. So I'm going to run this code. Okay. So we're just seeing the output here. So the first thing, and I'm going to run this again just so we can kind of zero in on it. We'll print students in poetry. So who was added? Loki, Arius, Obi, Alexa, Minerva, and Dora. So these were the students that were appended to it. Now let's take a look at all students. Now when we look at all students, it's Alex, Brianna, Sherry, and Danielle. Because when we use .pop, what happens is it removed the last value from the list. So basically what we did was we went through what we did is while the length of our poetry class was less than 6, we added the last value of our all students list. So the last element, so the first one would be Loki. We appended it to students in poetry while removing that element from all students. So we kind of did a big switcheroo. Does that make sense?
Yeah.
Awesome.
Yeah, I'll see if anyone has any questions about that
Great.
in the chat.
Awesome. So in the meantime, we're actually going to switch on over. We're going to leave this for a bit. If we have more time at the end, we can come back to this lesson, but I do really want to go over all those challenges with you. Okay, so I'm going to X out, and we're in CS101 loops, and we're going to take a look at this article that says loops code challenges. Okay, so our first challenge is to create a function named divisible by 10 that takes a list of numbers named nums as a parameter. And we're going to return the count of how many numbers in the list are divisible by 10. So first we'll write out our function. So def divisible 10, and our parameter is going to be nums. Okay, so what we're going to do is we have this list, and we'll see it here. In this case, we're going to look at 10, 25, 30, 35, 40. We're going to go through each element in that list, and we're going to return the number of times we have an element that's divisible by 10. So what I want to do here is I'm going to use the for each loop. So for I in nums. So that's how we're going to iterate through each value in our list. We're going to check if it's divisible by 10. So if I modulo 10 equals 0.
Also, just for anyone who might not know what modulo is, the %, it's really cool. Basically what it does is it just checks the remainder you have when you divide that number by 10. So if it was 11 mod 10, it would be equal to 1. So we're checking for numbers that are divisible by 10 that wouldn't have a remainder.
Exactly. Thank you, Jamie.
Yeah.
So if our value is divisible by 10, we want to add to count. but that means we need to create a count variable. So before we even go into our for loop, the first thing I want to do in this function is declare a variable called count and set it equal to 0. Then we'll loop through each value in nums. If the element is divisible by 10, we're going to increase the value of count by 1. And then finally, outside of the for loop, once we've iterated through every element, we're going to return the value of count. So let's go ahead, we'll run this code. Okay, so it returns 3. And let's see, if we check our answer, is this correct? It's correct. Cool.
With the clapping hands.
I love the clapping hands. So again, we'll just go through this one more time. So our first value was 20. And since it's divisible by 10, we increase count by 1. Then we go back to the top of our code. We go back to the top of our loop. We check, is 25 divisible by 10? It's not, we ignore it. Now we're at 30. 30 is divisible by 10. We increase our count to 2. And then we are going to go ahead to the next one, 35. Not divisible by 10. We ignore it. Then we have 40, our last value. Now our count increases to 3. And then since that's the last value, return the value of count. And that's how we solve this.
Yeah. I think another good practice when you do like little challenges like these is you can write your own test cases to test like any edge cases, or for instance, like all these numbers that we're testing against are all, oh my God, not floats. What's the other thing called? Ints.
Double?
Ints.
Oh, ints.
Yeah.
Got it.
Ints. So we might want to test, if we did 20.0 versus 20, like, will that work? You might want to test, I don't know, like different, kinds of numbers, because all these are like 2-digit numbers. Yeah, definitely like something to consider when you're doing these little code challenges.
So that's actually a great point. So I was curious. So we turned our 20 from an int to a float just by adding that decimal point, and it still returns the same value. And the nice thing is we can increase this list. There's nothing that's stopping us. So I'd say 100, 234, 247, 190. It still runs the same code. You can see that we don't have to do too much more. And now it returns 6. Yeah. Okay. So now let's go on to our next coding challenge. Delete starting even numbers. Write a function called delete starting evens that has a parameter named list, LST. The function should remove elements from the front of LST until the front of the list is not even. The function should then return LST. And let's take a look at an example. So if our list was 4, 8, 10, 11, 12, 15, and then we called delete starting evens with it, it should return 11, 12, and 15. Now, the reason for this is we're going to delete 4, we delete 8, we delete 10, because it's an even number. So make sure your function works even if every element in the list is even. Okay, so let's give this a try. So it's def delete starting evens. It's going to accept LST. Okay, so one thing that kind of struck out to me is the word until. It will remove elements from the front of the list until the front of the list is not even. To me, that sounds like a condition. So for this one, I want to go through it using a while loop. Okay. So while, and we're going to create that condition, let's see, LST, while it's first index, right? Divided by, well, modulo 2 equals 0. So this is how we're going to check that it's even. So while index 0, actually, nope, we want to stop when it's not even. So while the first element of our list is not an even value, what are we going to do? So what this is going to involve is changing our list value, LST. So what I'm going to say is LST equals LST. So you might remember this a little bit from last week when we were talking about splicing or getting sub values from a list. Okay, so what this means is we're changing our value of list to include every single value except the one at index 0, right? So 1, this represents the first index. Then this colon here kind of represents until, and then it's blank here because we're going to say until the end of the list. Okay. So that's what we're going to do. And now let's see what happens at the end. We return list. So to check this out, let's take a look at this first example here. Let's run this code. Okay. I think it was supposed to be, oh, I'm sorry, we were supposed to do equals. So while the first element is an even number, my apologies for that. So while our first element is an even number, because when we use modulo 2, the remainder is 0, we're going to return list equals list at the first, at index 1 and beyond. And again, since we're looking at 0-based indexing, it just removes that first value. Okay, so here we go. We have 11, 12, and 15. Now let's make sure this one works over here. And I'm gonna just spoil you guys and say that it's not gonna work. We have an index out of bounds error. And that's because at one point we delete every single value in this second list here. So 4, 8, 10. So we just kept deleting it, deleting it, deleting it. So once it hit that 4th iteration and it goes to reach for the index at 0, there's nothing there. So that causes an error. So we need to add one additional condition before we check if there's something at the 0th index. So this is when we're going to use, it is the length at LST is greater than 0, and.
Yeah. And if any of you watched the control flow live stream a couple weeks ago, this is kind of similar to that, where it's we talked about how you might have like multiple conditions in like within like in those cases it was like an if or an elif statement, but in this case it's a while statement. So that way you'll only go into the while statement if both of these conditions are true. So that will avoid this error that we just ran into.
Exactly. Yeah. So that was the problem we ran into. And so now what we're going to do is, while the length of the list is greater than 0 and the first value in our list is an even number, we're going to run that code. So this should stop it from giving us an error, because once we see that the length of our list is 0, or once it's 0, it's going to say, okay, forget it, we're going to return that value. And let's see if running this works. Okay. Now we see it just returned an empty list. So now we know that we're working with the edge case that we might have a list that's all even values.
Yeah. So. Also, Giannis brought up a great point in the chat. He said, so where you put the LST equals LST, like where you splice the list, you could also decide to like delete the item in the list that you're currently on using the delete function. There's also, I really like this code challenge. There's also a lot of different ways to do it. You could technically do it using a for loop as well. It might be more difficult with a for loop, where you just like loop from the beginning. And once you get to, are you trying to get to an odd number or an even number? I think once you get to an odd number, then you can like stop the loop. There are definitely a lot of different ways you can do this. And a lot of times when I have coding challenges like these, I like to just like maybe write out on paper, like think in my head, like, okay, what am I doing at each point in this like little algorithm, and like how can I translate this to Python code?
Yeah, I totally agree with that. Always write down your plan, and it makes coding so much easier. And that's the nice thing about loops, like we discussed before. In a lot of cases, they can be interchangeable. Okay, so we have about 5 minutes left. So let's see if we can get through this final code challenge. create a function named reverse list that takes two lists of the same size as parameters. And we're going to name those parameters LST1 and LST2. The function should return true if list 1 is the same as list 2 reversed. Otherwise, we'll return false. So looking at this example, if we send in a list that has a value 1, 2, 3, it should match the value 3, 2, 1. So the first element matches the last, the middle matches the middle, and then the last element of the first list matches the first element of the second list. Okay, so let's get into this. So we'll create this first. So it is def reverse list. So reverse list, and we're going to take in the parameters LST1, LST2. So because we're working with two lists, I kind of don't want to use just a for each loop or I'm iterating through it. I think I'm going to use just our normal for loop where we're going to define that range. So let's see, for I in range. And what I'm going to do is I want this to start at 0 and go to probably the length of one of the lists. And because it already said we're assuming that the parameters will always have even sizes, that we don't have to worry too much of that. So I'm just going to say length of LST1. So just to give you guys an idea of what we're working with, I'm just going to print, let's see, LST1 at I. Okay. So I'm going to take this bit of code here just because I want to call the function without returning anything for a bit. So we'll run this code. So we can see it takes out 1, 2, 3 because we used I. But what about if we're trying to use LST2? What happens when I run this? Well, it gives us 3, 2, 1. But what I really want is I want it to almost flip it. I want that last value to be printed first. But how do we go through a list in reverse? Now, I'm not sure if you know this, but we can actually put in negative index values. So index at -1. So I'm not going to do this inside the for loop, actually, changing my mind. I'm going to do it right outside the for loop. And we'll just comment this. So what happens if I try to print this value? Loop expected.
Oh, I think it's because you have the for loop and nothing below it. You can write, oh yeah, just comment out.
Let's take that out. So you can see that we're now getting that last value of 1 here because I use -1 as the index value. I can do this so at -2. You can see it's 2, -3. We can run that. And now what happens if I try -4? We're going to get an error because it's index out of range. So again, just keep that in mind. So now that we know that we can kind of use negative values to help us out, how can we use that to help us in our for loop? So before we were using I, right, to print out each value of LST1. But now I want to switch this to LST2. But I want to use something with this negative value. So we know that if we use -1, we can start counting backwards, just like we did before. Now, what if we decrease it by I? So if we took the value of -1 minus I, what do we get? 1, 2, 3, which is our loop in reverse. So if we look at an example of this, in our first one.
Alex, can you zoom in potentially? Because someone just asked if you could zoom in for visibility.
Definitely. I hope this helps a little bit more.
Yeah, thank you so much.
Cool, of course. So we're taking a look at this. So in our first one, I is 0. -1 minus 0 is -1. List 2 at -1 is this value 1. And so then in the next one, in the next iteration, I has a value of 1. -1 minus 1 is -2. LST2 at index -2 is 2. So now that we know how we can get those values, we're going to use a conditional. So let's see. So if LST1 at I is not equal to LST2 at -1 minus I at that index, just like we discussed before. If it's not equal, we know it's false. So we're just going to return false. And if we get through that whole loop and we never run into a case where they're not equal, then we know that they're equal and we'll just return true. Okay. So I'm going to take this out and we're going to try and see if this works. Okay, so we're going to run this. Okay, so our first value is true. 1, 2, 3 matches 3, 2, 1 in reverse. Now let's try that over here, where we know looking at this 1, 5, 3 does not equal 3, 2, 1. Run it, and now it's false. Yay!
Yay.
And we'll check our answer, and we got the clapping, and everyone should clap for themselves because that's pretty awesome.
Yeah. So
it is 2 o'clock, so we are going to have to end this, but you should definitely join us next Tuesday for another CS101 live course. I believe we'll be going over strings.
Yep.
So it's going to be really fun, and we look forward to seeing you there. Definitely check out our events page where you can register for it, and you'll get an email that reminds you when we're about to start our stream. All right. Thank you again, Jamie. Thank you, everyone, for joining, and we hope you have a great rest of your day.
Yeah. And thank you so much for all the great questions and wonderful comments in the chat. Hope to see a lot of you at future live streams.